Metal-clad cable without an overall jacket is a specific type of metal-clad cable designed without an outer jacket or covering. Its applications primarily lie in industrial and commercial settings, valued for their flexibility and robustness. The metal-clad cable you commonly acquire from a supply house will likely have an overall jacket. Metal-clad cable lacking an outer jacket represents a specialized product with less common usage. When utilizing metal-clad cable lacking an overall jacket and adhering to the stipulations outlined in National Electrical Code Section 310.15 Exception Number 5, it might not be necessary to implement the 50% adjustment factor. It is important to confirm with the cable manufacturer that it adheres to the mentioned exception. Employing metal-clad cable that lacks an overall jacket and fulfilling the criteria of exception number 5 could lead to considerable savings in time and effort by avoiding the 50% adjustment factor. National Electrical Code Section 310.15 addresses the ampacity of conductors. Ampacity refers to the current in amps that a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. Several factors influence a conductor's ampacity, including the ambient temperature, the number of current-carrying conductors in a raceway or cable, and the type of insulation. Adjustment factors are applied to reduce the allowable ampacity of conductors when certain conditions exist, such as high ambient temperatures or multiple current-carrying conductors in close proximity. These adjustment factors are crucial for ensuring the safe operation of electrical systems. Exception number 5 to National Electrical Code Section 310.15 provides a specific exception to the application of adjustment factors for Type AC cable, armored cable, or Type MC cable, metal-clad cable, without an overall outer jacket under certain conditions. These conditions are: firstly, each cable must have no more than 3 current-carrying conductors. Secondly, the conductors must be number 12 American wire gauge. Thirdly, not more than 20 current-carrying conductors are bundled, stacked, or supported on bridle rings. Metal-clad cable without an overall jacket refers to a metal-clad cable where the metallic sheath serves as the primary protection without any additional non-metallic outer covering. This construction differs from standard metal-clad cable, which typically includes a plastic or other non-metallic jacket over the metallic armor. The absence of an outer jacket can affect the cable's heat dissipation characteristics and its suitability for certain environments. The exception provided in National Electrical Code Section 310.15 is based on the understanding that metal-clad cable without an overall jacket has better heat dissipation characteristics compared to metal-clad cable with a jacket, especially when the number of conductors in the bundling are limited. This improved heat dissipation allows for a higher ampacity without exceeding the conductor's temperature rating. The 3 conditions specified in the exception are designed to ensure that the heat generated by the conductors can be adequately dissipated. Limiting the number of current-carrying conductors to 3 per cable reduces the overall heat generated within the cable. Using number 12 American wire gauge conductors, which have a smaller cross-sectional area compared to larger conductors, also helps to limit the heat generated. Restricting the number of bundled conductors to no more than 20 ensures that the heat can escape from the bundle effectively. When these conditions are met, the adjustment factors specified in National Electrical Code Section 310.15 are not required, simplifying the installation and allowing for higher allowable ampacities. It is crucial to verify that the metal-clad cable being used truly lacks an overall jacket and meets all the conditions specified in the exception. This verification should include consulting the cable manufacturer's specifications and markings on the cable itself. Incorrectly assuming that a cable qualifies for the exception can lead to overheating and potentially hazardous situations. The 50% adjustment factor mentioned in the original context likely refers to the adjustment factors specified in National Electrical Code Section 310.15b2, which addresses the number of current-carrying conductors in a raceway or cable. This section requires reducing the allowable ampacity of conductors when there are more than 3 current-carrying conductors in a raceway or cable. The specific adjustment factors vary depending on the number of conductors. For example, when there are 4 to 6 current-carrying conductors, the allowable ampacity must be reduced to 80% of its original value. When there are 7 to 9 current-carrying conductors, the allowable ampacity must be reduced to 70%. And when there are 10 to 20 current carrying conductors, the allowable ampacity must be reduced to 50%. These adjustment factors are intended to account for the increased heat generated by multiple conductors in close proximity. The heat generated by each conductor can affect the temperature of the other conductors, potentially leading to overheating and insulation damage. Therefore, it is essential to apply the appropriate adjustment factors to ensure that the conductors are operating within their safe temperature limits. The exception provided in National Electrical Code Section 310.15 Exception Number 5, as discussed earlier, provides an alternative to these adjustment factors under specific conditions. If the metal-clad cable lacks an overall jacket and meets the other requirements of the exception, the adjustment factors do not need to be applied, allowing for a higher allowable ampacity. This can be particularly beneficial in situations where space is limited and it is difficult to install multiple raceways or cables. By utilizing metal-clad cable that qualifies for the exception, it may be possible to reduce the number of cables required, saving time and materials. However, it is crucial to carefully evaluate the specific conditions of the installation and ensure that all requirements of the exception are met. This includes verifying the cable type, the number of conductors, the conductor size, and the bundling configuration. If there is any doubt about whether the exception applies, it is always best to err on the side of caution and apply the appropriate adjustment factors. In addition to the number of current carrying conductors, other factors can also affect the ampacity of conductors. These factors include the ambient temperature, the type of insulation, and the presence of other heat-generating equipment. High ambient temperatures can reduce the ampacity of conductors by increasing the temperature of the insulation. Different types of insulation have different temperature ratings, and conductors with higher temperature ratings can generally carry more current. The presence of other heat-generating equipment can also affect the ampacity of conductors by increasing the ambient temperature in the vicinity of the conductors. Therefore, it is essential to consider all of these factors when determining the appropriate ampacity for conductors in a given installation. The National Electrical Code provides detailed guidelines for calculating ampacity and applying adjustment factors. These guidelines are based on extensive testing and research and are designed to ensure the safe operation of electrical systems. It is crucial for electricians and electrical engineers to be familiar with these guidelines and to follow them carefully when designing and installing electrical systems. Failure to do so can lead to overheating, insulation damage, and potentially hazardous situations. In summary, metal-clad cable without an overall jacket is a specialized type of cable that may qualify for an exception to the adjustment factor specified in National Electrical Code Section 310.15. This exception can simplify the installation and allow for higher allowable ampacities under certain conditions. However, it is crucial to verify that the cable meets all the requirements of the exception and to carefully evaluate the specific conditions of the installation. If there is any doubt about whether the exception applies, it is always best to err on the side of caution and apply the appropriate adjustment factors. The National Electrical Code provides detailed guidelines for calculating ampacity and applying adjustment factors, and it is essential for electricians and electrical engineers to be familiar with these guidelines and to follow them carefully when designing and installing electrical systems. The type of metal-clad cable typically found at supply houses generally includes an overall jacket. To determine if the metal-clad cable you regularly use qualifies for the exception, firstly, check the cable for an overall jacket. If it lacks an overall jacket, proceed to the next step. Secondly, confirm that each cable contains no more than 3 current carrying conductors. Thirdly, ensure the conductors are number 12 American wire gauge. Fourthly, verify that no more than 20 current carrying conductors are bundled, stacked, or supported on bridle rings. If your cable meets all these criteria, it may qualify for the exception. However, the final step is to contact the manufacturer and verify that the specific cable you are using is listed and approved for use under National Electrical Code Section 310.15 Exception Number 5. This verification is crucial because not all metal-clad cables without an overall jacket are necessarily designed or tested to meet the requirements of this exception. The manufacturer's documentation should provide clear information on whether the cable is suitable for this application. If the manufacturer confirms that your cable meets the requirements, you can then apply the exception and avoid the 50% adjustment factor, potentially saving time and effort. It's also important to document this verification for future reference and inspection. Keep in mind that electrical codes and regulations can vary by location, so it's always a good practice to consult with local electrical inspectors or authorities to ensure compliance with all applicable rules.